In today's lesson, we are going to look at the components of vectors. So in the previous lesson, we looked at vectors in general. We talked about how they have a magnitude and a direction, and we looked at how we can basically write them or identify them. Now we're going to look at the components, or what are vectors made up of. And in most applications, it makes sense to think of a vector in terms of rectangular components. Basically what we mean are horizontal and vertical components. So what we want to do is write each of these vectors as as rectangular components. So if I take a look at the first one, right, we have this weight. There's a 25 Newton force being pulled 30 degrees at an angle of 30 degrees from the ground. So I want to break this up into two components. This is my vector right now. And I want to break it up into two components. I have the horizontal component. However you want to label it, was called the horizontal vector, right, or horizontal component. Oops. And I want to break it up into a vertical one as well. So I have two components I'm trying to break this vector up into. And this is going to require us to recall our trigonometry. So this is going back a couple units. So for our horizontal vector, right, if I were to just basically name this a triangle, right angle triangle, the horizontal and vertical make a right angle. I know 30 degrees and I know 25. Right? If I'm going to start with the horizontal, if I'm labeling my sides, I have my hypotenuse already. I have my angle. This would be the adjacent. This would be the opposite. So for my horizontal side, or the adjacent, I would have to use adjacent and hypotenuse, which is cosine. So I have cosine 30 degrees is equal to adjacent, which I'm going to call my H component. Use the absolute signs as well, right? Because it's going to be a positive value no matter what. So H over the hypotenuse, which is 25. Bring the 25 up. 25 cosine 30 is equal to H, or the horizontal component. And I get that the horizontal component is 21.6 newtons. So the horizontal component is 21.6. For the vertical component, let's see what color we do this one. For the vertical component, same idea, except we're using the opposite, right, and the hypotenuse, right? So if this is that was the horizontal, this is the vertical. So I'm using opposite and hypotenuse, which is sine. So sine of 30 is equal to opposite, or the vertical component, over 25. Bring the 25 up. Actually, I need to just identify this is something different. Oops. Let's do this. Sorry about that. I'm just trying to keep everything a little bit color coordinated just so we're consistent. So 25 sine 30 is equal to the vertical component. And we get that the vertical component is 12.5, and the units will be newtons. So therefore, now we have our two rectangular components. So we would say, therefore, this vector could be written as 21.6 newtons along the ground and 12.5 newtons up. For the next one, again, similar idea, same idea. We're looking for the different components. Right, so here we have our angle downwards, right, or our vector is heading down. We need to break this up into into our rectangular components, so horizontal and vertical. Now there's two ways that you could do this one. You could represent it this way, or you could represent it this way. Right? So we have two different ways that we could draw the triangle. Either one is fine. It would just change whatever angle you're using. Right? So you're either doing something like this. This is still 5, but then this angle would have to be, actually let me do the other one first because I know I can usually work through that. So if I go through this way, right, there's my 90 degrees. This is 5. This angle would have to be 15 degrees because if the entire thing is 105, right, 90 to east, then 15 from east to the vector. The other triangle I could draw, this would have to be 75 degrees. Right? So either way you choose to do it, you should still, let me just make this a little bit neater. 75 degrees, and this is still 5. So either way you choose to draw it, your triangle, you're still going to get the same idea. Right? It's not going to change what the horizontal and the vertical components are. So it doesn't really matter which one you choose. I'm going to pick this one just because the triangle is laid out a little bit nicer. Right? So if I want the horizontal and the vertical components, the horizontal, we have the vertical. In this case, based off of the angle, right, my horizontal is my opposite, the vertical is the adjacent, right? So again, those two components, they could change whether the opposite or adjacent depending on what angle we're given. So if I want to find the horizontal, opposite over hypotenuse, this one I'm using sine. So sine 75 is equal to the opposite, or in this case, the horizontal, over 5. Bring the 5 up, so 5 times sine 75 equals the horizontal. I get the horizontal is 4.8, and it's going to be meters per second. Right, so I'm just using whatever units are already given in the vector. So that's my horizontal component. My vertical component, because it's adjacent, is going to be cosine. So cosine of 75 is equal to the vertical component over the hypotenuse, or 5. Bring the 5 up, so 5 cosine 75 is equal to the vertical component, and we get 1.3 meters per second is equal to in the vertical component. So now that I have these two portions, I can rewrite, or I can say, let me just move this up to write a little bit lower. What I can say is that therefore, right, instead of saying the 5 meters per second, 105 degrees bearing, I can say it is 4.8 meters per second, and horizontal in the direction that we're going would be east, and 1.3 meters per second south. So those would be the two, the rectangular components. Right, so I can represent them as two vectors, essentially, a horizontal and a vertical vector. So next, a baseball is hit with an initial velocity of 80 kilometers per hour at an angle of 60 degrees to the ground. First, we want to sketch the diagram and then break the velocity down into horizontal and vertical components. Right, so I'm just going to roughly sketch this one. We have along the ground, we now have 80 kilometers per hour. We have 60 degrees from the ground, and I want to break it up into the two components, right? A horizontal and a vertical. Right? I need to figure out what those two are. Right, so if I'm going to draw the triangle just without anything extra, just so I can identify what trig ratio I'm going to be doing. So I have my triangle, 60 degrees, it's 80. My horizontal component. Sorry, I'll do that after. I'm going to label my side. So hypotenuse is already done. Opposite is across. Adjacent is beside. The adjacent represents the horizontal. The opposite represents the vertical. Now I have enough information that I can go through and determine the two components. So I'm going to go through. For the horizontal component, I'll do that one first. It's adjacent over hypotenuse, or I'm finding the adjacent, so I have to use cosine. So cosine 60 is equal to the hypotenuse, or sorry, not the hypotenuse, the horizontal, or the adjacent, divided by the hypotenuse, which is 80. Bring that up, 80 cosine 60 equals hypotenuse, or horizontal, and we get a value of 40 kilometers per hour, which is equal to the horizontal. For the vertical component, it's going to be sine. So sine of 60 is equal to the vertical component divided by 80, the hypotenuse. Bring the 80 up. Sine 60 equals the vertical component. And I get a vertical component of, say, 69.3 kilometers per hour. So what I can say then is, therefore, it's going to be 40 kilometers per hour along the ground. It's not a specific direction, but it's along the ground. And then I have 69.3 kilometers up. So those are the two components. I can also write the vectors differently as components if I have a grid. So I can write them, right, in component form, where I list the two, or the how do I say it, the length, or the rise and the run, so to speak, right? So if I look at PQ, I've gone over 4 and I go up 5. So I have a horizontal and a vertical component. So 4 and then 5, right? So if I was to look at this, the first one is the horizontal, and then the second one is the vertical. So CD can be written in component form. CD is negative 6, 5, right? Because I'm going in a different direction. I'm going backwards 6, so I'm going over 6, or in the negative direction, negative 6, and I'm going up 5. So if I wanted to write negative AB, or the negative vector negative AB in component form, this is AB, right? So AB would actually equal, if we go and we do the horizontal, would be 1, 2, 3, 4, 5, 6, 7. Would be 7 and 2. But negative AB, wouldn't be both components negative. It would just be going in the other direction. So we might say, oh no, it would be actually my mistake. If it's going the other direction, it'd be negative 7, negative 2. Right? Because the negative vector, or the opposite vector, would be the same direction and magnitude, just going in the same magnitude, but going in the opposite direction. So we'd have the same horizontal and vertical components, just negative because they're going in the opposite direction. Now, if we're given the vector in this form without the magnitude, we can actually go through and figure out what the magnitude is by using the Pythagorean theorem. Right? So if I were to look at PQ, right, I know the horizontal and the vertical components, so I can find the horizontal one by saying that it's we'll say the horizontal. Well, let me start with what the Pythagorean theorem is. Right? If you don't remember, a squared plus b squared equals c squared. So if I wanted to write this out, a squared might be the horizontal component squared plus the vertical component squared equals the actual vector or the magnitude squared. So 4 plus 4 squared plus 5 squared equals the magnitude squared. So we get 41 is equal to the magnitude squared. To get the magnitude by itself or the measurement by itself, I take the square root. So that means the magnitude PQ is equal to the square root of 41. CD, again, the nice thing about the Pythagorean theorem is that when you square these negative numbers, it doesn't really make a difference. So I can say negative 6 squared plus 5 squared is going to equal the magnitude of CD squared. So I have 36 plus 25. The negative just cancels out. So I have 61 is equal to the magnitude squared. So that means the magnitude is the square root of 61. I'm going to leave it as a square root. I could go through and evaluate what the actual value is, but I'm going to leave it as this because it's not turning into a nice value. So I might as well keep it as the exact value. For AB, oops, similar idea. We know it's 7 and 2 for the horizontal and vertical components. So 7 squared plus 2 squared is equal to the magnitude of AB squared. So 49 plus 4 is 53. So 53 equals the magnitude, and then take the square root. So the magnitude of vector AB is the square root of 53. The last one, if point S has coordinates of -2, -1, determine the following. Right? The vector ST if the point T has coordinates 3, 1. Right? So I'm just going to put the points down roughly in a random spot. So if this is S and this is the point -2, -1, and T is at 3 and 1, so we'll say somewhere about here. I want to know what is this vector, right? ST. So in order to do that, I just need to figure out, I could go through and do the magnitude, right? But I don't have a direction. But what I can do is I can use the component kind of notation for it and figure out what is the horizontal and what is the vertical. Well, the horizontal is coming across. So if I go from -2 to 3, so -2 to 3, or I can do 3 minus -2 to figure out the difference, which is 5. And then the vertical component, same idea. I can do 1 minus -1, and I get 2. So that means the horizontal component is 5, the vertical component is 2. So therefore, say the vector ST, let me scroll back up to make sure, equals, I could say 5, 2. So that's the vector ST in component form. What are the coordinates of point R if vector RS is 6 and 3? So RS is 6, 3. I know S, oops. So if S is here, R has to be somewhere down here. So we didn't talk about this too much, but RS, basically it's telling us what the start and what the end is, right? So R is the first part, S is the ending. So when I'm drawing it, it's going to head in this direction. So S is going to be the ending. I know S is -2, -1. And if I know the horizontal of 6 and the vertical of 3, I can work backwards to figure out what the components are, right? So r, right, if I'm looking at the x value or the horizontal component, if I move back 6 from -2, this would have to be -8, right? Or -2 minus 6 equals -8. Let me put this in green. And then for the vertical, right, -1 minus 3 equals -4. So that means then that the point R is -8, -4. Right, so this lesson was just focusing on breaking down vectors into a horizontal and vertical component, understanding how to find the horizontal and vertical component if we are given angles and given degrees and magnitudes. There's also ways that we can figure out the horizontal and vertical or the magnitude if we are given just the vector on a grid. So that's just breaking it up into x and y coordinates and using Pythagorean theorem. So two different ways to kind of come up with these vectors or to come up with the different components depending on what we're given or how we're given the vector, right? Whether it's like an angle like we see here, or whether it's more of a line on a grid or a vector on a grid. But either way, it's still breaking them up into horizontal and vertical components.